How was lunch? Good? You know, after yesterday with the burritos, I was a little bit disappointed. I kind of half expected to see the sign say cold burritos today, but you know, what can you ask for? It's conference food. So today we're going to be talking about back-end architecture for mobile apps. And it's a fun topic. In fact, it's a little bit too fun of a topic because there's so much going on with it. There is just really so much what have yous. There's so many choices to be made. There's too many choices. And so today we're going to be going through a couple of options that you can make. And there's no one right choice that you can make in all situations. And in fact, there's no one right choice that you can make in any specific situation either. So I'm not going to be able to give you something that you can come out of here and say, this is what I'm going to do. But there's pros and cons for each architecture that we're going to talk about today. And so hopefully that when you come out of here and you take it to your specific application that you're building, that you can weigh the pros and cons and be able to pick an architecture or maybe a couple different architectures and weave them into your app and have a successful application experience with them. So my name is Matt Sokup. I am a senior cloud advocate at Microsoft. And what does that mean? It means I heart developers. I want you to be successful in anything that you're building, whether it's a Xamarin app, whether it's a native iOS or Java app or Android app, whether you're building React Native, I want you to be successful building that. In fact, my DMs on Twitter are always open, CodeMillMatt. If you're having any issues at all, I want you to get in touch with me. Whether you're even building a mobile app or not, if you're building a .NET Core application, whether you're building a Docker, get in touch with me. I'll be able to put you in touch with somebody else if I don't know the answer. But even more importantly, I want to be your advocate within Microsoft. So if you have an idea for an application or for a product that would be better for one of our products, for a feature, or if you're having trouble with something, or if there's a bug that we can fix, I want to be your voice within Microsoft to make sure our community is well represented. So with that said, we're going to start off with a flash quiz. How many people have ever developed an app that did not have to talk to the internet? 1, 2, 3. Yeah, it's more than I thought. I had to do one, and I had to struggle to think of the answer, and it was back in 2009. It was the very first mobile app I ever created. You would think that this would be front of mind. And it was, it's a long story, but it started out as an iOS app in Objective-C, went over to a Xamarin app because I got myself into a lot of trouble because Objective-C is a terrible language. And it had GPS functionality in it, so a little rudimentary geofencing, but so I'm not sure if GPS counts for internet. Still, one app out of all these years, over 10 years, that didn't have to talk to the internet. So most of the people are now developing apps that talk to the internet. It's rare, very rare. 3 people didn't have to. And all those apps that are talking to the internet, how many people have developed their own cloud of it, whether it's on-prem or talking to Azure or AWS or even some other vendor? So what we're doing is not only just talking to things like, let's say, a Twitter feed or some other third party, we're developing our own things as well. In fact, we're doing such a good job at it, developing our own clouds, that we might come up with something like this, or we have a bunch of different microservices or a bunch of little clouds in it. And those little clouds could be developed in a bunch of different languages, and they could be sitting on-prem. They could be sitting on different cloud vendors. They're all over the place, and they do different things. They're written in different languages, possibly. And microservices are a good thing, and we'll get to talking about that in a bit. But so not only do we have to develop apps for something that looks like this, which happens to be an iPhone, we have to do something for Android as well, and a bunch of different screen sizes, a bunch of different operating systems. Really, when you consider Android and iOS, we have to go backwards compatible for it. Now we have to do this too. And so nobody has ever been wrong when they said mobile app development is tough. It's bad, right? It gets worse when you put in cloud development with it or back-end architecture with it, because there's so many things that you have to consider with it. And so mobile backends have some unique needs that go along with them. The first is API versioning. If we're going to write a backend, we have APIs with it, we have to make sure we version it. We release a brand new feature, we have a brand new app, not everybody's going to update to that. So we have to have our APIs backwards compatible. Now, whether we do like a V2 in our routing or we put it in the headers or something, we have to make sure our APIs and our apps are capable of handling API versioning. Unique for mobile. Offline data, the bane of every mobile app developer's existence. Users are going to find a way to go offline. While they're offline, they're going to find a way to change the data. At the same time, they're going to find a way to change the data being online on a totally different device, and when they come online with the first device, the data is going to collide and be in a conflict. We have to have a way to resolve that conflict too. Push notifications. Not every app has push notifications, but it is a unique need across all mobile backends that we should account for push notifications being sent out. And then finally, debugging is rough for mobile backends. Debugging's rough for just mobile front ends, but we start mixing in cloud or even just plain old networking into it. We have to take into account, well, the first is disconnected. Then we have to take into account intermittent connectivity, take into account slow connectivity, the fast connectivity. Android, when you're debugging the emulators, runs on a totally different network on your computer than what iOS does. iOS simulators on your regular network, Android runs in its own little network that you have to create a bridge for. It gets really maddening having to do this, and nothing really substitutes for having a device in hand to test with. You can write all the unit tests you want, but you still want to have a device in hand to check around for. So debugging's tough. Plus, mobile backends have what I'm saying are table stakes. In order for a mobile backend to be called a mobile backend, you have to have these features within it. First off is scalable compute. And here, this is your business logic. This is your app logic. And you want, ideally, you're writing something and you want a ton of people using it, so you want it to be able to scale out. You don't want it to collapse under load. At the same time, if nobody's using it, it'd be nice if it scaled back in, so you don't get charged a bunch of money for it. Authentication. You want to be able to authenticate people or personalize and make sure that you lock down resources. Data and file storage. This gets back to what we were talking about before with offline data sync. Well, you want to be sure that you can also handle just pure online data and file storage. You have a database in backend. You want to be sure that you can communicate with it. And also file storage. Here I'm talking more like blobs, static data. And then again, push notifications. The table stakes, you want to be sure you can handle push. And there's more. There's more that we want to consider when we're building our mobile backends. Cost. We're not unlimited. We just can't throw money at it. We have to consider cost. Productivity. Now, here what I'm talking about is not only us being productivity, and I'm a Xamarin developer, so I know C# and I know .NET pretty well. However, if I have on my development team a bunch of JavaScript Node developers who happen to be really good, let's say, in supply chain management, I don't want these people to have to learn C# and .NET in order to write a backend for me. Let them work in Node. I want them to get up and running quickly. So I want my mobile backend to be essentially language agnostic. And unfortunately, not everybody's a mobile client. So we want to have our backends be ready to be able to serve a bunch of different front ends. Now, whether that front end is your traditional web client, like an Angular or a React application or a Vue application, or even like an IoT app. So we want to start thinking through that type of stuff to make sure it's there, for when in the future, or even the present, that more applications, more front ends can access it. So there's a lot of possibilities that we can use to build our apps up. And three of them that I'm going to talk about today, first are web APIs, the traditional web API, like a .NET Core or a Node.js app, and using containers to build these up. Serverless, Azure Functions. And then finally, mobile backend as a service, or MBaaS. Now you'll notice one thing I'm using for the logo here of MBaaS Visual Studio App Center. And you might be thinking, well, VS App Center, if you're familiar with it at all, doesn't have any MBaaS features or any mobile features, table stakes that we talked about before. It has push notifications, but it doesn't have data. It doesn't have authentication until tomorrow. You heard it here first. Actually, they're designing it in the open, so it's known. It's going to be in preview tomorrow that people can start playing with it. All right. However, none of these, you could go all in on one if you wanted to, but most likely you're going to be mixing and matching to build your backend up. You might be using some web APIs to do some more heavy lifting. You might be using some functions to do some event-driven processing. And you might be using the mobile backend services because it packages things really nicely for you. And you get them for free. It's not free, but you get the ability to write with them for a low amount of investment in typing. So let's take a look at what we're going to be using today, what we're going to be building up to use different backends. And it's called Tailwind Traders. It is a, here we go. And I'm going to minimize the, all right. Now you see, this is right here, debugging stuff. Look at my Android emulator that I had set up and ready to run. That makes sense, right? It's Android, never works. There we go. Really big. I'm going to just kill it for now. All right, so here's Tailwind Traders. It's a demo app that was created by Microsoft to show off a bunch of different Xamarin 4 features. It was released at Ignite last year. What I did is I took it and made it work with a bunch of different backends just for this particular talk. And it's a shopping cart. You can go out and you can view different products. So right here, you can view this sponge, for example. And if you wanted to add this safety cord to your shopping cart, you hit Add to Cart, and it says Item Added. So it's not really very complicated, but it shows up a couple different microservices running in the background. And so this is what we're going to take a peek at, see how we can architect this in a couple different ways to make it work better for us. All right. So the components of it are a product metadata service. So the one that returned the picture and the name. So we have that product service that I'm calling it. We also have the shopping cart service, the one that allows users to add things to the cart, to then purchase them as well, or remove things from the cart. And purchasing in this case really just means deleting it from the database that sits up in Azure. And then inventory. There is an inventory one. You might not have seen it. It just says how many of these happen to be left. And it gets obviously decremented whenever somebody purchases something. So 3 relatively simple as far as the business domain services are. But we'll see how we can put these together and use them. So first up I want to talk about is how we can do this in what I'm going to be calling traditional web APIs. Node.js using a MongoDB backend. ASP.NET also using MongoDB for the shopping cart. And then ASP.NET Web API using SQL Server as a backend for the inventory. So let's just see this one in action then. All right, and so how are we doing with the font back there? We're good, we can see? All right, excellent. All right, so the web or the mobile application really are just all we can be concerned about today are 3 services: the product service, inventory service, and the shopping cart service. The whole UI really doesn't matter for what we're concerned with today. And these services, what they do is they call out to there, and they are using a third party, or not a third party, an open source product called Refit to communicate up there. So that's how we're doing the communication. All right, so we're using right now the web APIs. And so to get the products, one thing I wanted to call out is to get at them, I am handling using Monkey Cache, another open source product, And I'm manually, as you can see, going through and saying, all right, first off, if I have internet, and if it exists, I'm popping everything into the cache. So I'm handling the data myself. So in order to build up this backend, I'm doing work. I'm doing work on the front end. I'm not getting anything for free here. And then finally, I'm calling the WebAPI, get my products before I get them back. Inventory over here, to get the current inventory, I'm not checking the cache at all because I want the current inventory as it is. If nothing exists out there, if I get a WebAPI exception, I'm just returning 0. Probably not the smartest thing to do, but it's a demo. And so again, it's built up by hand. And on the shopping cart, same thing. It looks a lot like the product service. Using Monkey Cache to build everything up, and then calling out, getting the cart items for the user, putting them in the barrel, returning them. When I add them to the cart, again, I'm building it up. So what I'm saying, when I'm building them up, I'm not getting anything for free, so to speak, with my data, with my offline caching. I have to build it up myself. So here, when I add it, intentional bug, is if I'm offline, if I have internet, I'm going to call up to the web API and pop it in. Great. If I don't have internet, I'm just adding it to the cache so I can still see it in my app, but I'm doing no checking afterwards to actually add it in. So it's a bug, and it's just an example of work I have to do to make sure that things sync up. It's a pain when I have to start doing it. I have to start thinking through all this stuff. And then in the purchase cart here, again, if there's internet, I'm going to go out and actually purchase everything, but I have to actually check for an exception coming back. And it's a conflict exception in this case, and then really should handle it here to do something. And in this case, I would pop it up to the user. All right, so now looking at the backends. The inventory controller happens to be written with C# and Entity Framework to talk to SQL Server, which is kind of neat. So I'm using a full Entity Framework. It's .NET Core, but it's robust. So by using the Entity Framework, I can actually do like get inventory by SKUs, which calls out to an inventory manager, which is using Entity Framework. So it's what I'm trying to get across here, web APIs, verbose. And what I'm going to do here is start it up so we can see how we can debug. So as that starts up, shopping cart. Again, the shopping cart exception occurred, SQL client exception. Aha. We are not SQL Server. Granted firewall. All right. All right, good. So then shopping cart. One thing I want to call it here with the shopping cart is that during the purchase part, I'm using MongoDB. Again, just using the .NET Core version of MongoDB. And here, just checking out which items I have in the database currently, which items I passed up to it, and just seeing if they match, essentially, by doing a little link checking over here. If they don't match, I'm handling it myself. I'm handling everything myself, and that's what I want to get across here. And then for the product service. Product service is written in Node.js. It's JavaScript. I wouldn't know JavaScript from TypeScript. I heard a giggle, right? So I wouldn't know JavaScript from TypeScript, right? I don't know it. However, I have a team of developers that do. So what I can have them do is I can have them put this up into a container for me. And in this container, I just happen to have it in Azure Container Registry. And what I can do, and we could put it in Docker Hub just as easily, but I can take this Tailwind product service and download the latest tag and then debug against that. So right here, I'm just showing out the various Docker images that I currently have. And then I'm going to use the Azure CLI to log into my registry, my ACR, then Docker pull it down. So Docker pull. And so what that's going to do, ideally if I can talk to it, is go out and grab it and pull everything down for me, and then extract it and install the image. And we can see that right now we have it right here. And so this next one, I'm going to actually start it up. And it's just a Docker run, passing in some environment variables, and saying, all right, I want it to run on port 8000. So I'm going to say clear. All right, so now I have it up and running on 8000. So I'm going to be able to now not have to worry about it. My Docker container is up and running. My JavaScript folks have told me it's good. I don't need to test it. So it's up, it's contained, great. Then everything I have here is just, I'm running on localhost. Localhost 9000 for the shopping cart. For inventory, localhost 5000. And then for Docker, or for my product service, 8000. Start it up. And we're going to build iOS, so it hopefully doesn't take as long as Android. And then since I already had it installed, when I go out and try to grab products, it's not going to hit the database at all. If I show over here on the Docker side, I don't have anything. It would log if I was. But when I go out and try to get the inventory, I can actually go through and debug from it. So now I'm going to see my SKUs go through. So it's allowing me to debug through VS Code and see it all in there, which is pretty nice. And I can actually, if I go through here and add it to the cart, or adding the item, I think I know why, and I can then break into shopping cart. And the reason why is that it's not started. That's what I was getting my error for. So, but that's the point, is that I can actually run the Visual Studio Code, running my web APIs, debug from Visual Studio on a Mac. Same thing over if I was using Windows. Now, I could actually, if I wanted to, debug into a Docker container with the latest VS Code extensions as well. It's in preview on the Insider builds, just released a couple days ago. And on Visual Studio 2017, you're able to do that for a while. So just because it is a Docker container doesn't mean you can't debug into it. But the idea here is that you have your web development team say, hey, this is good, this is solid. They pass it over to you. And you don't have to worry about it. You still can debug your Xamarin application up against it. And one other thing that I do want to point out, when you do eventually deploy it up to Azure, to be able to scale it out, it's going to go into a app service plan. And to be able to scale it out, it's actually pretty straightforward. All you're doing is you're going to be able to scale up or scale out. And you can set up enable auto scale and just pump up the instances, or change which pricing tier you're on. And you can go to super expensive with a ton of ACUs and memory and such. So it's pretty easy to get more horsepower behind your application to hit the compute stuff. So to judge how the web APIs stack up against the unique mobile needs of things, the API versioning, I didn't touch on that, but you are going to have to roll your own again. So you're going to have to come up with a way to version things, and you're going to have to call that in a unique way from your app as well. Offline with conflict, we took a quick look at that. Again, you're rolling your own. Push notifications. I didn't touch on that, but I will be with VS App Center. Yes, but with a little bit of work. We have Azure Notification Hubs. Notification Hubs provides an SDK which makes it relatively easy on the server to call out and do push notifications of Firebase and Apple APNS. However, there is going to be some work setting it up initially. So once you get that done, it's relatively okay, but you have to do a little bit of work. And debugging, it's not too bad. It's not too bad once you get it all set up and rolling. So to handle the unique needs, you're doing a lot of rolling your own. So backend table stakes, scalable, yes. Authentication, I didn't touch on that. I have a ton of content around authentication. Codemailmatt.com, or you can tweet me and I'll send it to you. Yes, again with work, same thing with push notifications. You can hook it up with Azure B2C. We have an MSAL library, Microsoft Authentication Library. You can hook it up, but you're doing a little bit of work to get it all hooked up. Data in file. It's not too bad to actually talk. I was talking to Cosmos DB, I was talking to SQL Server. It's not too bad, but you are rolling your own essentially. And then back to push notifications, yes, with work for the table stakes. Then the things to keep in mind with the web APIs. More than mobile? Yes. Just have to think of it that way. But these are just web APIs. These are REST services. Easy onboarding. Productivity? Yes. We had Node.js. We had ASP.NET. If your people they know the frameworks and they're business specialists in the area, away you go. Cost? Could be better. At least for the way I demonstrated it, I had Azure Container Registries running. I had app services running. If we did push, we'd have notification hubs running. It adds up. So it could be better, and these things are always up and running. The intangibles. Here's the things that kind of help it out and kind of push it and make it really good. You get nice, fine control over data caching and memory management. So what's neat here, if you're using SQL Server on your backend, because you can use like Entity Framework, or you can just use the SQL data.SQL client, or system.SQL client, you can fine tune your connection string. And you can hold up a nice connection pool open. So you don't run out of connections to your SQL Server. So you can really fine tune your caching and your memory management. You could use native libraries and full frameworks if you want. If you needed a C library in there or something like that, you could go this way. Always running. You won't have, if you choose to do it, you don't have to worry about cold startup or anything like that. Lots of languages available. Pretty much whatever you want to write it in, Go, Python, support it. You're writing it yourself. You could get bare metal performance here. You could have a container that's GPU optimized. So if you're doing a bunch of machine learning that you wanted to do, you get a request in and you have to spin it out to do machine learning or something, this is the way to go, because you could have containers doing just a ton of work right at the bare metal. And it's in process, and what I mean by in process is once the request comes in, you have everything else loaded up. It's not event-driven, per se. And we'll talk about Azure Functions next. So to learn more, I have a couple short links right here. The first one brings you to Microsoft Learn. And if you haven't heard about Microsoft Learn, it's actually super, super cool that you should check out. What it does is that you are able to spin up your own version of Azure. I should mention, it's free, and you get a step-by-step tutorial as you run through. So here you can actually create a container, you deploy an app service to it, and you just run through the tutorial as your command line interface as you go. So it's really cool to check out. The second one is just the documentation through all the app service container stuff. All right, Azure Functions. Here, everything's going to be in C#. It's my language, my wheelhouse. This is what we're going to be dealing with. Still with MongoDB, but SQL Server for the inventory. So let's take a peek at it, how it's going to work. The front end is going to be exactly the same, which is very interesting because when I was writing this talk, I was debating with James Montemagno, and I was saying I couldn't understand why anybody would ever want to write a function or write a backend not using functions. And he was purely on the other side. He kept on saying, I would just write it with WebAPIs all the time, every single time. So we had to disagree on that. And the reason why I would always go with functions, because, well, we'll talk about that in a second. And I'm actually not on that camp anymore for several reasons that we talked about, that they're always in process and you can actually, container way is pretty cool. However, your front end stays the same. You are going to be rolling your own data handling. You're going to have to handle your own offline conflicts. If you're doing push notifications, you have to handle it yourself. If you're doing authentication, you have to handle it yourself, and so on. What changes, though, is in the back end. All right. So what I have here is this shopping cart functions, get all products, and inventory functions. And so our get all products, there's no ceremony here in setting it up at all. It's just this. So before there was opening up Mongo and taking care of the Mongo connection and everything, here it's just product collection as queryable to list async. And in the product connection, I'm actually going through here and telling it which product connection I want, or what collection I want here. But that's it. And it's saying it's an HTTP trigger. I'm not actually starting up a node server in the back end at all. I'm letting functions take care of that for me. It's even better in inventory. Inventory, I still can handle a SQL Server on the back end, but where I might run into trouble is on functions, because it does scale out really great, is I might start running out of concurrent connections to my SQL Server, possibly. So that's something I have to worry about. But I can work around it by doing something like this, where my run decrement inventory, I instead start writing to a queue, an Azure storage queue. And this queue is actually neat because I'm doing a binding. And this binding, all that takes to actually write to it is doing right here an IAsync collector, and then this. So it's just an attribute to an object, and that's all I need to talk to another Azure service, right? So this is where functions really starts to shine. And it's event-driven. So run decrement inventory, there's no ceremony involved. I'm explicitly saying what I want to do with it. Here it is. This is my incoming right here in the route. Puts it in the queue, performs the decrement, and returns it. So you can imagine the handle inventory queue here. We might be doing something else. It might be going out and talking to some management service where we need to actually order something else if it gets down to a certain level, more where I don't want my mobile client to wait for all that to happen. However, like shopping cart functions though, purchasing it, it's the same thing. I have to go out and check and do all my data calculations to see if I'm getting a conflict or not. So functions really is the same as WebAPI. It's just a programming model. It's event-driven, and it's a lot less ceremony in setting it up. So, and it makes sense though, because functions itself is running on a app service as a backend as well. So it really is kind of, sort of, like a WebAPI. But you're not worried about setting up all the infrastructure. That's taken care of behind the scenes. And you're just worried about writing your app logic. You're just concerned about writing exactly what you know. And you can write them in a bunch of different languages, or Java, or JavaScript, and Java. and C#, and so on. It's really, so it gives you a lot. And you can actually write functions in a container as well. So let's just take a peek at this. For when we want to debug, I'll change it all over to run functions locally. And then I'll start this up. All right. So rebuilding on iOS, because it doesn't take forever like an Android would. Great. Products, again, are cached locally, so I don't have to worry about that, because I didn't change any of my local code. But as soon as I try to purchase an item, again, now I'm hitting, and then now I'm into my run purchase items. I'm going to run through that, and right here, I have hit the route of the run purchase items in the function. And I should, once it writes, hit the queue, which I might have not set a breakpoint for. But we'll keep on chugging here. All right. So what functions gives you is API versioning. Again, you're rolling your own. You can actually set your routes. Right here, it's fairly easy to set up your routes, but you're rolling it yourself. Offline with conflict, again, you're rolling it on. Push notifications, version 1 with functions had it built in just like the storage queues. Version 2 with functions, you're going to have to build it yourself. So it's going to be the same thing as you were doing with a WebAPI. Debugging, not too bad. Again, you can run it locally, just plug it right in, set breakpoints, and debug that way. The table stakes, scalable. Functions are wonderful for scaling, and they scale down to 0 when you're not using them. Authentication, same thing with WebAPI. Data in file, yes. There's a little more work to it to hook up with everything. And then push notifications, again, yes, with work. So then some things to keep in mind, more than mobile, yes. Easy onboarding, yes, because they support all different languages. And actually, it's a little bit easier onboarding because of all the bindings and the triggers that function supports to other languages. And the cost is good because it scales up and scales down for you. So the intangibles here, easy Azure integrations, great for more than just HTTP. And so a lot of the functions are running not based on HTTP triggers. You can be based on Cosmos inserts. You can be based on Event Hub events coming through. So there's a lot of cool things running that you don't have to build your functions off of. And they're great at scaling, And there's something called durable functions. So by default, functions don't have state. Durable functions do. So they give you a way to orchestrate things, kind of like logic apps, but they are able to inflate state as you go through to help with long-running processes. So same thing as before. Learn module at top, documentation at the bottom for functions. All right, App Center, or MBaaS, Mobile Backend as a Service. Everything here, cool thing about Mobile Backend as a Service is it gives you everything. You're not really rolling yourself for anything. You get it all, and then you're just making tweaks to it, essentially. So, Demo App Center, right? Not really. It's in preview right now. I didn't get the bits until too late, so how about some slides? For authentication, if you're familiar with App Center at all, you notice that the auth and data there at the bottom are new. And so what you can do for auth is you click on it, and now you can start hooking in to Azure B2C. And so what they have done is that they've made a seamless transition to Azure B2C, and they've also wrapped the Microsoft Authentication Library as well to make that a friendlier API to use. Data, the same thing. Data supported by Cosmos, supports offline sync as well, conflict resolution eventually. And so this also hooks up through that. And what I'm going to show off, though, is that they've made their App Center does a great job with their SDKs. They do a wonderful job with their SDKs. So good that I'm going to show off their push notifications. So push notifications are kind of tough to implement. And by that, let's see, we're going to start up Android. So to get push notifications working, generally what you have to do is talk to Google, Firebase, talk to Apple, handle a lot of things within your platform projects to hook everything up. So the App Center push notifications, what you have to do is just download this Google Services JSON from Firebase, change a little bit into the assembly manifest. Essentially, you're just adding right here. And this is all stuff that App Center gives you. And then the SDK, what it looks like to handle a push notification is this. App Center start, and you're just passing in type of push. And down way at the bottom, it's just push notification received. So they wrap everything very nicely for you. And so let's push this up. And so here, going to push, make sure we start up, getting a build, one error. All right, I'm not going to try to debug it. However, it would work great had the debugging worked. So what I'm trying to get across here is that a mobile backend as a service wraps things up really nicely so you do less work. So some App Center, unique mobile needs, you're still going to have to roll your own API versioning. So API versioning is something that you're going to have to do pretty much no matter what. It does, though, give you a nice way to handle offline with conflict. You're still going to have to figure out how you want to handle it, and by that I mean which one wins, whether it's the server one or the one that's on the client, or if you want to ask the user, but it's going to automatically tell you that there's one. You're not going to have to build that in. Push notifications, it's there. Debugging, I'm not sure how tough or easy that's going to be yet. I haven't tried it. The table stakes, scalable. I don't know yet. Haven't tried it. Authentication, it's going to be there. It's built in. Data and file, it's there. Data is going to be there. Files coming up. And push notification, it is there. Some things to keep in mind. More than mobile. Right now it's just mobile. Eventually it will support more. Easy onboarding, not sure yet. Haven't used it. And cost, I will work on it. We're trying to push them down on cost. Make it a nice, really low cost, if not free, onboarding experience so people can use it and get going with it. So some intangibles is that you get everything together. you get the ability to have App Center tell you, hey, I found a conflict. Or hey, I'm going to handle the push notifications. I'm going to talk to Firebase for you. I'm going to talk to APNS for you and provide you with a nice SDK for it to handle everything. However, because it's handling everything, you're going to be playing with inside its box, so you might outgrow it eventually as your app goes, or as you come up with some weird requirements. However, it is being designed on GitHub. So you can go out and raise issues as they're making it and say, hey, this isn't working for me, let's do it this way. And they're very responsive. All right, so a couple other things that sit outside of any architecture that I want to talk about that apply to everything. One, blob storage, the other one, a content delivery network on top, and then something called Azure Front Door. So let's take a peek at these. So all the images that I was pulling down here have come from Cosmos DB, or the URL has come from Cosmos DB itself. Right here, this URL. And so I'm storing everything in blob storage. And you really, if you have static data, static binary data, you really should be putting that up into some sort of blob storage. And mainly because it's cheap for a lot of it. And what's nice about that then is you can pop it in here, and I can go through and actually view it, like 1000 and then 2051, and see my image of my pull record. But the really cool thing is that I can pop a CDN on top of it really easily. Just by scrolling down to Azure CDN in front of it, I could create a new endpoint. I've already have one here called bimacdn.azure.net. And so what the CDN is going to do is that it's going to put all my images on the edge of Azure. So normally, if I would put that blobs URL, it would have to go through several layers of the Azure network to find it. By putting it on the CDN, it's going to put it right on the edge. It's going to cache it, so that way a request comes in, and it's not going to have to negotiate through a couple server layers. It's going to be right at the edge of the network and be able to put it through. So I can get this endpoint name, and it's just going to be then my container name, folder, and it's TT, or I think it's just 2051, and it comes up that way. So it's right at the edge, and it's really easy to set up, but just by going through the blobs, give me a CDN, put it on there, and we have several different formats that we can do. Akamai, you can do Verizon. There's Microsoft has one as well, and it's really something that you should think about for when you're doing any static data hosting. Another one that I wanted to point out is what's called Azure Front Door. So a lot of the times is when you're serving a global application, is that all my services here were in West US, or West US 2 or West US. However, I'm going to bring up Cosmos because it has a map to it. Obviously, we have people over here in Washington, but I might have people who are on the West Coast or even down on the Pacific in Australia who might be wanting to use the application. And so if anybody over here would issue an app, a request, even though I might have Cosmos replicated here, they're still going to have to go over to West US to serve the data, to serve the request, and that's where it's going to grab the data from. So really, my data being replicated here is not doing me any good. And so what I can do is create this Azure Front Door. And front door gives me a designer then that I'm going to say bimafd.azurefd.net. So that's where all my requests are now going to be sent through. And now I set up some routing rules to it. So I'm going to say anything that's API inventory or API inventory wildcard, send it to this backend called inventory, and just forward on the route to it. And so this inventory right here, backend, I have several different backends set up here. I have one that happens to be already in Australia. I have one that's hosted in the East US, and then one over here that's actually hosted in the West US. So what front door then does is that it's pinging and checking the health of everything. And so when a request comes in, this bimafd.net, azurefd.net, is worldwide. And so based on whichever Azure front door that it hits, whether I'm making the request in Australia or Eastern US, it's going to see, all right, my backend pool, which is closest to me, is the healthiest. It's going to serve it from there. So it's just a really cool way that you can set up essentially an orchestration of your web APIs. You can put Azure Functions in here. You can even put your on-prem data sources in here as well to have it up to make a global microservice architecture through here. It also fails over very well. So if I had one of my services here, if I would actually disable it, it would fail over after a couple seconds and stop serving anything from East US at all. So it automatically fails over without me having to do any work at all with it. And there's a couple different health checks that I can do. So right now I'm just serving everything geographically the best, wherever lowest latency. All right, and then some good documentation for both the storage front door and the CDN that you can throw in front of it. So front door is actually really, really cool. All right, so what have we gone through? Well, we've gone through that we're able to essentially create a mess with our backend architecture, but we can make sense of it. And we don't necessarily need to make sense with it all by programming in Node or all by programming in ASP.NET. We can have a multitude of different microservices working together to have our backend hit it. And we can really mix and match our own adventure by going these ways. We can totally have a serverless architecture working with a web API that is managing our SQL Server connections. Or we can have that web API running in a Docker container that is built off a GPU or something that really needs performance. Or if we need to have our mobile backend handle push notifications where we're not really worried about customizing it, we can do it that way. So really it's up to us to analyze the requirements and know where each of these ones shine. And really context is everything. Where we have our unique needs of our app, we hit versioning, which we're always going to have to roll our own, unfortunately, but offline data sync or push notification. And then you have the table stakes, scalability, is push notifications and data, and also the miscellaneous such as cost and productivity as well. So everything that I talked about here is at this URL, including data and a deploy script to push everything up into Azure right away, including running everything off a container locally and up in Azure as well. I'll warn you, if you push it up into Azure running everything off containers, shut it off after you're done playing with it. And with that, I thank you very much. And please feel free to reach out to me anytime if you have any questions at all. Thank you.